Looking at question number 2 from our velocity time worksheet, 2A says, what's the velocity at 6 seconds? When we want to find a variable that appears on the y-axis of a graph, whatever that variable is, if it's a velocity on a velocity time graph, or position on a position time graph, or force on a force time graph, or momentum on a momentum time graph, whatever it is, all we're going to do is go up and over. So we're going to go over to 6 seconds, go up and over, and we get 4.0 meters per second. Now, sometimes there might be a tendency to make that negative 4.0 meters per second because the line is sloping downward. But remember, the sloping downward indicates that it's a negative acceleration. It's slowing down, not that it's a negative velocity. We're still going forward. The velocity is still positive. We're still moving in the positive direction. It's just that we're slowing down in the positive direction, giving us a negative acceleration. All right, what is the change in velocity between 0 and 8 seconds? Well, the final velocity at 8 seconds is 0. The initial velocity at 0 is 16. So we're going to say 0 meters per second, the final velocity, minus the initial velocity of 16 meters per second gives us negative 16 meters per second. So it doesn't mean that we're moving 16 meters per second backwards. It means that we're losing that velocity. We're moving forward, but we're slowing down in the forward direction. The acceleration of the object, well, we can think of that in 2 ways. The slope, or delta v over delta t, they both amount to the same thing. The rise in the slope would be the same as delta v, and the run in the slope would be the same as delta t. The acceleration of the object, we're going to say the rise, or delta v, is negative 16 meters per second, and delta t over the 8-second interval is 8, which gives us negative 2.0 meters per second squared. So, once again, the velocity is positive for the whole trip, but the acceleration is negative, because although it's a positive forward velocity, we're slowing down. And finally, the displacement of the object. This requires us to find the area. Area equals displacement. If this is a position time graph, displacement is easy. Position time graph, go up and over, subtract the 2 of them. But on a velocity time graph, the displacement is the area. The good news is for this one, the area is simply a triangle. The shape is simply a triangle. So to find the area of a triangle, we say 1/2 base times height. 1/2 of the base of 8.0 seconds times the height of 16 meters per second. Now, 1/2 of 8 times 16 gives me, I believe it's 64. And the units are meters. Take a look at this for a second. Where do the units come from? Seconds times meters over seconds. The seconds cancel. What am I left with? Meters. 64 meters. And intuitively, it should be, we know that it should be meters, right? Because we're finding a displacement, and displacement is measured in meters. But there's a little bit of verification, a little bit of proof, I guess, that it is meters. Number 3 on that worksheet says, what's the velocity at 12 seconds? This one's a little bit harder. Not 3A is no harder, but the overall question is a little bit harder because we have 2 different things happening. In the first phase, you can see that it's accelerating, the velocity is increasing, and in the second phase, we can see that we have a constant velocity. So 2 different things going on there. What is the velocity at 12 seconds? Well, once again, we're just going to go up and over. At 12 seconds, the velocity is 5.0 meters per second. What is the acceleration between 0 and 8 seconds? Well, remember, acceleration is either the slope. Some of you like to do the slope. The acceleration is also delta v over delta t. That's the way that I usually like to do it. How many people found the slope? How many people have found delta v over delta t? Okay, more people that way. Okay, it ends up being the same thing though, right? Delta v, the change in velocity is 5 minus 0 between 0 and 8 seconds. And the time is 8 seconds. So that gives me 0.625 meters per second squared. And it's positive. Right? It's positive because you can see in this graph that it's speeding up, that it's accelerating. The velocity is increasing. Now, the acceleration between 8 and 18 seconds. What's the velocity at 8 seconds? Tell me what the velocity is at 8 seconds.
5 meters.
Good, 5 meters per second. What is it at 12 meters or 12 seconds? 5. What is it at 18? So in other words, the velocity is 5 the whole time, right? It's constant. It's not changing. And if the velocity isn't changing, then the acceleration is just 0. You could calculate that by saying A is equal to delta V over delta T, but what is the change in velocity, delta V, in that problem between 8 and 18 seconds? 0. And 0 divided by 10 seconds gives me 0 meters per second squared. So it doesn't matter whether you do the calculation or whether you just recognize it. Since it's a flat line, the acceleration is 0. Both work. Finally, the displacement of the object. I don't know an equation. I don't know about you, but I don't know an equation to find the area of this shape. So what do I got to do? What do I got to do, Ben? Yeah, split into, well, you split into whatever you want. It's logical in this case that we go into a triangle and a rectangle, but you could do something like this. Like, I don't know why you would, right? But as long as you find the area of everything, it should work, right? There's more work in a case like this. Let's just do what Ben said, break it into one rectangle and one triangle. We'll call this A1 and this A2. The area 1, because it's a triangle, is 1/2 base times height. The base is from 0 to 8. So the base is 8. And the height is from 0 to 5. So we're going to say 1/2 of 8 times 5. I believe that's 20, isn't it? Pretty sure that's 20. And then let's find the area 2. It's a rectangle, so it's base times height. The base goes from 8 to 18. What's that base? If we're going from 8 to 18, it's 10. And the height is still 5. So we're going to say 10 times 5 is 50. Now, what's the total displacement? 70 meters. Now, listen carefully. We haven't seen one of these questions, but who knows down the road? If you had a graph that looked like this, do you see that, where it goes below the x-axis? This area up here would be positive, and this area down here would be negative. And you'd add those up as positives and negatives. So it's conceivable that you could end up with a negative value, or it's conceivable that you could even end up with a 0 value, no displacement. Because in this case, we go forward, and then what happens? We go backwards. So we could end up with 0 displacement. We could end up with where we started. Above the x-axis, positive. Below the x-axis, it's going to be a negative value. I want you to take a look at this question now, velocity time graph, all above the x-axis, so all positive values, right? Let's solve these, I believe it's 10 questions. Yes, these 10 questions that go along with this. See what you can do at your desk now for the next 4 or 5 minutes, and then we'll take a look at it as a class. Okay, time to take a look at this. Question number 1 says, what's the velocity at 1 second? At 1 second, we go up and over right here. Looks to be about 4.0 meters per second. Agree? How many people said 4? Okay, be careful here. One common mistake with a question like that is to go up and over from here, right, from the first vertical line. We go up and over from here, we get 8. But the problem is, that's not 1 second, that's 2 seconds. My intervals are 2 seconds there. So just be careful not to do that. Question number 2, there's a bit of a typo. This should say what's the velocity at 14 seconds. The velocity at 14 seconds go up, at 14 seconds go over, and once again, that's 4.0 meters per second. So what's going on here? We're speeding up, speeding up, speeding up, all in the positive direction. Are we stopping now? No, we're going at a constant speed of 8 meters per second. We're not slowing down. We're not speeding up. We're just going like we drive along the highway at a constant speed. And then what happens? We change direction? Do we change direction here? No. All we do is, what are we doing here? Slowing down. So we're still moving forward, but we're slowing down as we move forward. And then what are we doing here? Stop? No, we're going at a constant velocity again, right? So it's like you sped up to highway speed, and then you went at a constant speed, didn't change the speed, and then you realized, you know what, a little bit of snow on the road, a little bit of ice on the road, we've got to slow down a little bit. Okay, and then we go at a constant speed that is something that's lower, about half the speed. That doesn't mean that we're going in the negative direction or we've turned around or going backwards in our car. It just means that we're going slower than we were at our peak speed. All right, what's the change in velocity between 4 and 8 seconds? Between 4 and 8 seconds, right here, the change in velocity is what? 0. We're going at a constant speed. The velocity didn't change. It was 8 right here, and it is 8 right here. But not right there, actually. Should be right here, shouldn't it? Still 8 meters per second, and the change in velocity is still 0, but we should be a little bit more precise in where we measure it. What's the change in velocity between 0 and 2 seconds? Between 0 seconds and 2 seconds, well, we're going 8 meters per second. We were going 0, so the change in velocity is 8 minus 0, or 8 meters per second. How many people got that one? Okay, good. 5, what's the change in velocity between 10 and 12? Careful on this one. Between 10 and 12. My initial velocity was 8. My final velocity was 4. 4 minus 8 is, what is it? Yeah, it's not 4, it's negative 4 meters per second. That doesn't mean we're going in the backwards direction or the negative direction. The negative 4 just means what? That we're slowing down. What's the acceleration between 4 and 8 seconds? We can use the slope to do this, or the easiest way I would suggest is delta v over delta t. Delta v between 4 and 8 seconds is negative 4, and delta t between 4 and 8 seconds is 4. Negative 4 divided by 4 is negative 1. What does that negative mean? Backwards? Ethan? Just means it's slowing down. We're decelerating. Still going in the positive direction, but slowing down.
Since it's between 4 and 8 seconds, should it just be...
Oh, sorry, I went between 8 and 12, yes. Yes, or between 10 and 12, sorry. Yes, absolutely. Between 4 and 8 seconds, what's the change in velocity? 0. The time is 4, so that's going to be 0 meters per second squared. Good? Thank you for that. Sorry. How many people were sitting there thinking, like, that doesn't make any sense. What is he doing? Okay. Only one person said something, though? Okay, what's the acceleration between 0 and 2 seconds? Between 0 and 2 seconds, my delta v is 8. My delta t is 2. 8 divided by my time interval here is 2 between 0 and 2 seconds, which gives me an acceleration of positive 4.0 meters per second squared. Positive because we're speeding up in the positive direction. The acceleration between 10 and 12. Between 10 and 12 seconds. Okay, here's 10 seconds, 12 seconds. My change in velocity here is 4 minus 8. So remember, we wanted to either take the slope or use delta v over delta t. 4 minus 8 is my change in velocity. My time interval here is 2. So 4 minus 8 is negative 4. Negative 4 divided by 2 is negative 2. What's the negative mean there? Slowing down. Not that it's going backwards. You can get a negative acceleration if it's going backwards. If you speed up in the negative direction, that's a negative acceleration. But if you slow down in the positive direction, that's a negative acceleration, right, Dylan? Right, just off to the side here for a second, guys. If we had a graph that looked like this, and it was velocity versus time, this would be what? That would be a negative acceleration because we're slowing down in the positive direction. This would be a negative acceleration because what's happening there? No, we're not slowing down. Okay, this is 0, -1, -2. What's happening here? We're speeding up, aren't we? We're going from 0 to 1 to 2 in the negative direction. So here we're slowing down in the positive direction, going from 2 to 1 to 0 in the positive direction above the x-axis. And here we're stopping, 0 meters per second. We're reversing direction, and we're speeding up, going from 1 to 2 meters per second in the negative direction. So it's like this. Okay, if that's positive direction, I'm moving and I'm slowing down, and I'm stopping, and now I'm speeding up in the negative direction. Make sense? Does that make sense? They're both negative accelerations though, right? They're both negative accelerations. One is speeding up, one is slowing down. One is speeding up in the negative direction or slowing down in the positive direction. Okay, number 9. Oh my goodness, number 9, the displacement between 0 and 16 seconds. This does not look fun. We've got to break this up into all kinds of shapes here to find the area. If you were thinking it was just simply a matter of subtracting a couple numbers, you would be wrong. Okay, there's quite a bit of work to this one. I'm going to break this into a triangle, a rectangle, maybe another rectangle right here, and maybe a triangle right here. Oh, you know what? Just noticed something. I could do that, right? I could make it one less shape, which means a little bit less work. Is that okay? I mean, you could break it into whatever you wanted, right, as long as you can find the area of them. Let's call this 1, 2, 3, 4, and 5. Area 1 is 1/2 of 2 times 8. What did I do wrong? Oh. No. You're just misunderstanding what I was doing. I was just calling this 45, not 4 and 5. Okay? So area 1 is 8. Area 2 is is base times height. We're going from 2 to 10. So the base is 8. The height is 8. That's going to be 64. The area of 3 is its triangle. 1/2 base times height. The base goes from 10 to 12, so the base is 2. The height goes from 4 to 8, so the height is 4. That's going to be 4. And area 45 is equal to base times height, or goes from 10 to 16, so the base is 6. And the height goes from 0 to 4, so the height is 4. That gives me 24. By the way, you can, if you wish, just call this area 4. Okay, if you like that better than area. Yeah, if you want to be boring about it, then call it area 4. If you want to live a little bit, call it area 45. Add these up. 64 and 8 is 72, 76, and 100, I think, isn't it? Exactly 100. And finally, number 10, the one that I haven't gone over with you, the little bit of a challenge question to see if anybody could figure it out. Anybody think they have an answer for number 10? Yeah?
You take the displacement you just found and just divide it by the total.
Yes. The average velocity is V is equal to delta D over delta T, displacement over time, right? We've just found the displacement to be 100 meters. And the time here is 16 seconds. And what does that work out to be? Patrick, what does that work out to be? .25 meters per second. Now, you know that sometimes they're going faster than that, right? Sometimes we were going backwards. We're not saying that at any point the velocity is 6.25. We're just saying that on average it was 6.25. Just like if I drive to Edmonton, okay, my average velocity is 94 kilometers per hour. Well, like maybe I was going 110 and maybe I was going at 85 and whatever. But on average it was 94. Okay, that's what I've solved for there. Does that make sense?